Hey guys, welcome back. In this video and the future videos, all I'm going to do is show you guys examples on how to find a relative max, min, and where the function is increasing and decreasing. Now, if you guys have not watched the other videos, then you might really not understand the point of all of this. So please watch the other videos first on critical numbers and on relative max, relative mins, and increasing and decreasing. So once again, going forward, these are all going to be examples, and I hope they're helpful. Great, so I wrote here, determine where the function is increasing and or decreasing, and determine the relative max and the relative min, if any. So my first thing that I have here is my function, and this is going to be 9 times x squared minus 3 over x to the third. Before we even start, guys, take a look. Is there any place where this function is undefined? Absolutely, at x equals 0. Why? Because the denominator cannot be 0, all right? And that just means that there's a vertical asymptote at x equals 0. Do you guys remember vertical asymptotes? There's actually a vertical asymptote at x equals 0, but there's also a horizontal asymptote at y equals 0 because the denominator has a higher exponent, okay? Great. So how do we find relative maxes and relative mins? Well, first you have to take the derivative, and I did that for you guys right here. You can pause the video and you guys can see what I did, but I'm not really gonna go through it, but it's a quotient rule, okay? And after that, I cleaned it up. So right now we are here. Great. So this is the derivative after it's simplified and reduced, and here we go. What are the critical numbers? So I'm going to just say Cn. Well, where does the numerator equal 0? Well, the numerator equals 0 at plus 3 minus 3. Isn't that true? If I put a 3 here, 3 squared is 9. 9 minus 9 is 0. If I put a negative 3 there, right? Where is the denominator equal to 0? At x equals 0. So there are three critical numbers. Remind yourself that a critical number is where the derivative is equal to 0 or the derivative is undefined, okay? So once you do that, what we're going to do is we're going to put f prime. We're going to draw a number line. We're going to put negative 3, 0, positive 3, and we're just going to test some values. And where are we going to put those values? In the derivative, okay? So I'm going to pick negative 4. Well, in the numerator, negative 4 will give you a negative, right? Because 4 squared or negative 4 squared is 16. 9 minus 16 is negative, okay? And in the denominator, I have a positive. So anything to the fourth power is positive. So this here will give me a negative. Therefore, it's decreasing from negative infinity to negative 3. Now let's pick a number between negative 3 and 0, which is our next testing interval. So I'm going to choose negative 1. What would happen if I put negative 1 in here? Well, if you put negative 1 into f prime, you are going to get a positive on top and a positive on the denominator, so you're going to have a positive. Therefore, it is increasing from negative 3 to 0. And now let's pick a number between 0 and 3. 1. Well, guess what? It's going to be positive again, okay? So it's going to be increasing from 0 to 3. Oops, and I forgot something here. Now what happens between 3 and infinity? Pick a number. We're going to pick 4. If I put 4 in there, I get a negative. Once again, you guys can pause the video and make sure that you understand this and you are doing it alone, okay? So now that I get a negative, remember that you must plug it into the derivative, okay? Not into the original function. So with that being said, it's also decreasing from 3 to infinity. So the function is increasing from negative 3 to 0 and 0 to 3, and it's decreasing from negative infinity to negative 3 and 3 to infinity. So I'm going to just get rid of this number line first. No, I should not. Okay, I'm going to choose a different color. What happens if you go down, decreasing, and then up? Isn't that a minimum? So I have a min at negative 3 something. And then we got to be very careful here, okay? It goes up, but it goes up again, so there's nothing there. But once again, 0 is not part of the domain. So actually, even if it went up and then down, that's not a minimum. So you got to be very careful with 0. Now you go up and down, and you get a max. So what is the max? At 3 something. Well, 3 and -3, what? This is when you go back to the original function, because this is the picture of the graph, and you find the points. By you putting -3 there into the numerator, you're going to get 9 minus 3 is 6, so that's going to be 54. And then 54 over -27, because -3 to the third power. And that should give us about 2, I hope. Okay, it's very late right now. So yeah, 27 into 54 is -2. So the min is there. And then let's put a 3 in there, and I get 54 over 27, so my answer is 3, 2. So this is the min, and this is the max. And I actually put in the calculator for you guys. This is what the picture looks like. I want to just re-emphasize that this is the vertical asymptote, okay? This is the picture here. It goes like this, and it goes like this. Now, in this case here, I can sort of see that there's going to be a maximum somewhere and a minimum somewhere. So I used my calculator. I went and I plugged this into Y1, okay? And then, I don't know why the calculator does this, but basically there's a maximum at 3. 2.99999 is 3, essentially. 2, okay? And I don't think these, I zoomed in, so these are not really ones, okay? So the scale is off. Well, it's not off, it just doesn't go by ones, okay? And so I think it actually goes by 0.5. So this is 1, this is 2, this is 3, okay? And then once again, that's why we're not looking at the horizontal the same way, but that's that's +3, 2. And then you guys can go to your calculator, you have this plugged in, and then you press calc, and then you go find the minimum, and that's what I did here. And that says x is -3, y is -2, and that's what we showed here, okay? So that's how you find your max and your min. And just to confirm, it's decreasing and then increasing. So let's take a look, okay? So it's coming down and then going up, okay? And then it's, once again, it goes up and then down, and so up and then down. So what we did confirms. Now, soon I'm going to start discussing concavity with you guys, okay? So the way that it's shaped, okay? So that looks like a U, so it's going to be concaved up, and then this looks like a sad face, so concaved down. But I'm going to show you how to do that in future videos. But I hope this was fine. You basically take the derivative, you set the derivative equal to 0, you find the critical numbers, okay, where does the derivative equal 0 and where's the derivative undefined, and then you set up your table, you choose numbers in each interval, you plug it into the derivative, and you just take a look at the sign, and that tells you if it's decreasing or increasing, and remind yourself what a maximum and a minimum is. If you go up, then down, you hit a max. If you go down, then up, you hit a min. And then to find the actual number, you must plug it back into the original equation. Have a great day. Don't forget to subscribe. Don't forget to watch